Make sure you participate as well. I don't know if I actually hit that or not. Yes. Okay, so we are recording. We're going to start talking about parent graphs and graphing. So the first one that I want to start with is linear. And we may or may not get through this. We will see what happens. This is one of the longer sets of notes just because we have to graph everything. Usually I get through linear absolute value and sometimes I don't get to exponential, but you'll still have your assignment and you'll be fine. So don't stress out about that. All right. So then with linear, we have y equals mx plus b. Remember, I'm going to write it up here so you guys can see it. M was your slope, and b was your y-intercept. And I promise as the semester goes, my writing will get better. I haven't written just like you haven't in like days and days and days. So it's going to be a little bit sloppy to begin with. All right. So m is your slope and b is your y-intercept. So on these, we don't have a y-intercept, so we just have like a plus 0 there. So all of these, because they are parent graphs, are going to start at 0, 0, okay? So how do we graph it? It says plot at least 3 points and label the asymptote. So remember when we do linear, your y-intercept is where you start. So we start at 0. And then remember your slope is your rise over run. Rise over run. So we rise 2 and run 3. Rise 2 and run 3. And I go all the way across the graph just because I like it a little bit better instead of just making something crazy. So I'm going to ask that you go all the way across the graph of these. With your quadratics, with your exponential, you're probably only going to do 3. But with linear and linear absolute value, I'm going to ask that you go all the way across the graph and then connect the dots. So that's graphing linear. That's it. I think the first unit is the only one that we like super graph a lot. We'll get some that we use the graph to help us out, but not like I'm not going to say graph this one by hand pretty much after this unit. Okay, so just bear with it for this unit. We're going to move on down to this one. It's y equals negative 3x. Remember, it's a plus 0. We will get to some that have some y-intercepts. We're going to start with this first. So that means we start at 0. And then how do I make my slope a rise over run? How do I make negative 3 a fraction? You have to talk to me because this is how I run my class, okay? You have to talk. I don't want to call on you individually, just answer. If I have to, I will. But you know how to do this. This is not a hard question, and I don't ask hard questions usually, okay? So negative 3x or just negative 3, how do I make it a fraction? Zoomers, you can answer too. Thank you. Put a 1 underneath it. You guys know what it is. I'm not trying to trick you, okay? This says rise negative 3, which means go down 3, and always to the right. So I always use my negative with the top number. Does it mean up or down? So if it's negative, it means down, and then to the right 1. You can go completely opposite, up and to the left. And again, these are things that you guys know how to do. This is old school from Math 1. Math 3, the final exam is not just a Math 3 exam. It's a Math 3 and Math 1 and Math 2. Okay, so you'll find all of those concepts embedded, but I teach them all over again. Okay, so don't feel like you're not going to know, oh my God, I didn't know anything from Math 2. You'll know it. Okay, you'll be fine. All right, moving on down to the bottom. What's different about this one? Guys, please make sure you're on time from now on. What's different about this one? Say it again. It's a 3y, so I just need it y equals, right, to be able to graph it. So here, this is 3y. How do I get rid of this 3? Remember that we do opposite operations. So this is 3 times y. To get rid of it, I'm going to divide 3. I do the opposite operation. So my equation is actually y equals 4/3 x. And then you guys can put the plus 0. I don't need to see that. Again, guys, make sure you're on time. We start at 0. we do our rise 4 and run 3. So rise 4, run 3. You can kind of make it go off the graph if you want to. You don't have to. Like I said, as long as it stretches across the graph, it's not a huge deal. Or I can go down 4 and over 3. So it'll look like this. Again, called a parent graph. It's called a parent graph because it goes through 0, 0. Okay. All of these started at 0, 0. They were not moved left, right, up, or down. We will get into those translations soon. All right. I'm going to skip over to linear absolute value. Okay. They call it linear absolute value just to relate it back to linear. You can just call it absolute value. I don't have to have that. It's going to look the same thing. It's going to look almost exactly identical to linear equations. Again, that's why they call it linear absolute value. Where m is going to be your slope, but this time x is in absolute value bars, and then b is your y-intercept, just like it always was. Okay, so there is no difference in that at all. What you do need to realize, this one's easier because it starts at 0, 0, because we're not going to have that y-intercept or whatever. So it's going to start at 0, 0. And absolute values are V-shaped. Okay, so you possibly have not done any absolute value. Have y'all seen absolute value at all equations? You've probably solved them, but have you graphed them? Yes, no, maybe? Okay, you may not have. I don't know. It just depends on what your teacher did. Okay, so not a big deal. They are just like linear in the fact that you start at 0, 0, because we had a plus 0 right here. And then that 2/3 tells you what your slope is. So you go up 2 and over 3. But then I told you they were V-shaped, so they're a little bit like quadratics where they mirror each other. They're symmetric on either side. So you're going to go up 2 and over 3 on the other side. And that's what makes your V-shape. So that's what it's going to look like. We will eventually talk about what happens when we move that vertex away from 0, 0. Like I told you, we're just working on parent graphs now. So understanding how to graph when we start at 0, 0. All right. Same thing on the next one. We have negative 3x. And if you guys look, they're pretty much exactly like the linears. So this one has a plus 0 start. So start at 0, 0. How do we make this negative 3 a rise over run? We already did it. Put a 1 under it. Thank you. So then we go down 3 and over 1. And then we want to mirror it on the other side. So down 3 and over 1 to the left. Then it looks like this. Tell me 2 things that happened between these 2 graphs. Like we're going to compare and contrast like you do in like English, like characters or something like that. So these 2 graphs, tell me what's different about them between the 2 of them. One's what? One's wider. What makes it skinny and fat? You guys should have done this in math 2. Okay, not the negative positive. What's the negative do? Changes the direction. So the negative made it flip over. Y'all got that? So it made it upside down. You should know that from quadratic. You don't have to have it from absolute value. Everything works the same way. So the negative made it flip over. What made it get skinnier compared to being fat? The number, a fraction, or the number in front. Okay. So the first one was a fraction less than 1. So anything between 0 and 1 makes it fat. So I say fraction fat, but you got to be careful because it could be an improper fraction, which will not make it fat, but just bear with it, okay? So fraction makes it fat. The bigger the number here, not ignore the negative flips it over, but the bigger the number, 3, 4, 5, 6, the skinnier that it gets. So you might have heard stretch and shrink in math 1. I don't know if you heard it in math 2, but I know you heard it in math 1. So this is a vertical stretch because if you think about like putty and you pull it apart, that's a vertical stretch. And then this, making it fatter, would be squishing it down because when you squish it, you make it flat and fat. Does that make sense? So think about putty when you hear those words. That'll come in later. I tend to, when I teach, if you've never had me, like I kind of hint to what's coming. So that'll be coming soon, okay? Look at your next one. We're going to put the plus 0 on the end. What number is always in front of x if there's not one? 1. So this is actually 1, absolute value of x plus 0. How do I make 1 a fraction so I can do rise over run? Put a 1 under it. Guys, make sure you're on time for the Zoom. 0, 0, we're going to go up 1 over 1. It's a positive, so it should be pointing up or opening up. And then we make it mirror itself on the other side. So we always graph the right side first, and then we mirror the left side. Any questions so far? All right, so the really, really crappy ones are the next two. So quadratic and exponential, if you're doing this on your homework, I would suggest that you use your calculator, and I'll show you that in a few minutes. I just want to show you how to do it by hand because eventually we're going to be making these equations. So you do have to know how to do that. But when you do these, we're still going to have the plus 0 on the end. That's going to cause us to have a point at 0, 0. But what you can't do is use your slope because now it's x squared instead of being x, okay? So what you have to do is I just make a little chart and literally pick random numbers, okay? We know that it's going to be pointing which way. Does it open up or does it open down? Up, right? So I'm going to pick some numbers on this side, on the right side. I'm going to pick some numbers on the left side, and it should be graphed up here. How do we know that? The 2 is positive. So I'm going to pick 1, okay? So I'm going to pick x is 1, and then I'm going to plug it in. 2 times 1 squared. What is 1 squared? Come on, guys, quick. 1 squared.
1.
Times 2, thank you.
2.
2. So my coordinate is 1, 2. What do you know about it? It mirrors on the left side, right? Quadratic is that U shape. So I can just go ahead and get this point as well. Remember, it said label 3 points. That's as good as it needs to be for me. That's all you have to do, okay? So get 1 point on the right and then mirror it on the left, or get 1 point on the left, mirror on the right. And we know it's U-shaped. Just make sure that you make it U-shaped and not V-shaped. Look at the difference in my graph, okay? Make sure it's U-shaped and not V-shaped. All right, so what about the next one? Again, it's plus 0, so we're going to start at 0, 0. Which way is this one going to point? Down, because it's negative, right? Okay, so this one's going to point down. So I can do 1 again. That's perfectly fine. I'm going to do x and y. And my x is going to be 1. And I'm going to plug it in. Negative 3 times 1 squared. 1 squared is 1 times negative 3 is negative 3. So that means my coordinate is 1, negative 3. 1, negative 3. It mirrors. So I'm going to do it on the other side. Again, make sure it is U-shaped. So I'm fine with what's here. Just make it more U-shaped than V-shaped. They're really quick, okay? So don't try to plot 50 points. You don't need to plot 3 and that'll be enough. The vertex and 1 on either side is going to be plenty. All right. The next one, same thing. We're going to start at 0, 0. This one is positive, so it's going to point up. Positive is up. You're going to pick any random point. I'm going to pick 1, and I'm going to plug it into the function 1 squared, which gives me 1. So my coordinate is 1, 1. This one's kind of tight. If you want to go ahead and do another point, that's fine. You can do these in your head. It doesn't matter. If I did 2, 2 squared is 4. So I get 2, 4. And then I can mirror it on the other side. Sorry, I kind of missed that point. Just again, make it U-shaped. So that's where I'm going to be pretty picky, okay? Make sure it's U-shaped compared to a V-shape. Don't make it pointy. You can see the difference between these two. Make the V shape pointy, make this one U shaped. All right. So same thing for the next one. The only difference is in exponential, your y-intercept is not 0. Okay, your y-intercept is not 0. So when we look at this, sorry, that's a B. Got a little excited there. A times B to the X, that doesn't have your A on there because we don't have one. This A is your y-intercept. And for parent graphs, your y-intercept is always going to be 1. So this equation that we have right here would look like this. 1 times 2 to the x. 1 times 2 to the x. This is going to be your y-intercept. So we're going to start this one at 1. We need 3 points. Let me explain exponential to you. Exponential you probably haven't had since Math 1. I don't know that you do any exponential for real in Math 2 at all. I can't remember if you do or not. It's been a long time since I taught Math 2. You might hit it every now and then, but it's not strong, okay? So Math 1, we had exponentials. Remember, I call them the Nike check graphs. So when you graph an exponential, I'm going to flip my notes over for a minute so you guys can just see this. It's going to come really close to 0, and then it's going to shoot up really fast. Okay, so it kind of swoops. All right, it'll always have a horizontal asymptote. Right now, our parent graph is going to be a 0 asymptote because we're not adding or subtracting, moving it up or down or left or right. So right now, today, your asymptote is going to be at 0. If you forgot what an asymptote is, that's a vertical or a horizontal boundary, okay, that it can't cross. So for this one, you're going to have to do like you do quadratic and just plug in some points. So I'm going to do it over here, a chart, an XY chart, and I'm going to plug in 1. And then we're going to do 2 to the 1. What is 2 to the 1? 2 to the first power. 2. Everybody good? So my first coordinate, I'm going to write it over here so it's not blocking everything up, is 1, 2. Remember, we need 3 coordinates. I'm not going to do the other side because that's going to get me into fractions and I don't want to deal with that, okay? So I'm just going to estimate the other side because we're just sketching. I'm going to do 2. 2 squared is 4. So my next coordinate is 2, 4. I plugged in 2 and I got 4. That is all you need. So for this side, this is what I'm going to look for, especially on your test. This is what I'm going to look for. You're going to go as close as you can to 0 and then sweep it up to those points. If you cross 0, I'm counting it wrong because remember, that's our horizontal asymptote and it's not supposed to cross it, okay? Get as close as you can, but don't cross it. All right, so again, sorry, I'll leave that up for a second. This next one is 3 to the x. Where's our y-intercept? 1. So we're going to put our dot at 1 if you need to write that, because it's actually 1 times 3 to the x. There's your y-intercept. And then we make our chart. We're going to plug in 1. So 3 to the 1 is 3. So our first coordinate is 1, 3. And then I plug in 2. And like I said, I don't go to the left side because that's going to give you nasty fractions and you guys don't like fractions and decimals. So we're just going to guess that side, okay? We're just going to guess that side. So 3 squared is 9. And I can't get that on here, and that's fine. If you want to try to throw it up there somewhere, that's fine. Get as close as you can to 0 and sweep it up. Again, do not let it cross 0. And then one more of these and we'll move on. We have 4 to the x. Remember, we can rewrite that as 1 times 4 to the x. The only reason I'm doing this is to show you where your y-intercept is. Our y-intercept is at 1. We're not moving it up, down, left, right, so it's going to stay at 1 for right now. That's why it's a parent graph. So all the rest of them have coordinates starting at 0, 0. Exponential starts at 1. Okay, everything else 0, 0. Exponential is 1. We're going to do our XY chart. We're going to plug in a 1, and 4 to the 1 is 4. So our first coordinate is 1, 4. If we try to plug in our second coordinate, we get 16. That will be too hard. Here's what I want to show you just in case. If we plug in -1, I don't have my calculator on me, we would get 1/4 or 0.25. You can do that if you want to, but it's really crappy to graph as well. Okay, so just do the best you can with the other side. So -1.25 would be like way down there. You can't even graph it anyway because your pencil's too thick to graph 0.25 on this. Okay, so go as close to 0 as possible. Sweep it up. I will look for those 2 points right there. That's what I'm looking for. Any questions on this first page, how to graph? Again, you should be able to do it. You guys, when you do your homework or your tests or your quizzes or anything like that, use your calculator and get your points from the table. I don't care. You don't have to know how to graph it by hand. But what we're going to eventually do is translations, and you're going to have to know those translations by looking at them. So you need to know the parts of the graph or the parts of the equation before we start talking about translation. So that's why we're reviewing it. This is all review, everything you should know. The only thing would be absolute value. Okay. Then we have some special cases, and those special cases are horizontal and vertical lines. So horizontal lines have the equation y equals, it's always y equals, because it crosses the y-axis at 2, and that's the only axis it crosses. So it's going to look like this. It crosses the y-axis at 2. The next one says x equals -3. That says it crosses the x-axis at -3. So 1, 2, 3, that's where it crosses, and it only crosses the x-axis. Those are the ones that are the most missed. Everybody flips them around. So I try to relate them. Y equals means cross the y-axis. X equals means cross the x-axis. Okay? So don't forget that. All right. So the hardest thing is domain and range. Okay? I think this is the hardest. Sometimes making the equations, which we'll do in a minute, are the hardest. But domain and range tend to be the hardest for people. The first ones you can see are normal ones. So I'm going to start with those, start with the normal ones, and then we'll get to these ones with the crazy holes and stuff. You guys seen graphs with holes before? Okay, so that's good. So we're going to start first with linear. I want to go to linear. It's the easiest one. Remember, linear is a line. Domain is how far it stretches left to right. So if we look at the linear, on the left and on the right, we see arrows. What do those arrows mean? How long does it keep going? Forever, right? Forever and ever. So linears are the super easiest. It keeps going to the left forever. So it's going to be -infinity. Remember, we always write it least to greatest. And -infinity will have a parenthesis because it is not included. It's not a real number. It's a direction. Does everybody understand that? Infinity is not a number. It's a direction. All right. So then the other side on the right is going to go to positive infinity forever and ever. All right. If we think about this graph as a compass, like the compass that tells you which direction to go, north, east, southwest, right? This one is pointing northwest, right? What does north mean? What do you think about when you see north on a map? Which way would you move? Up, right? So it goes up. How long does it go up if it has an arrow? Forever. This one would be pointing southeast. We already did east to west, right? You guys remember that. We already did east to west. Now we're doing north to south. How far does it go south? Forever. So always, always, always linears, as long as they don't have any holes, gaps, whatever, are negative to positive infinity. Negative to positive infinity. Sometimes relating these to directions like in geography or whatever can help you think about like up, down, left, right. Okay. Sometimes it's too hard to look at it. Like this one, people are thinking, oh, it only points up. It doesn't. What else does it point? Which way? You don't have to do east. What's this hand? To the right. You don't always have to do that. It's just to give you a visual. Okay, so this one is to the right and up. So don't forget that. All right. Let's go to absolute. No, let's not. Let's go back to this one. Go back to this one. I'm going to do that domain and I'm going to leave the range alone for right now. Okay. I wrote R, but we're not going to do it yet. This graph has arrows on both ends. What is the only special case in this graph that you guys see? You don't have to be specific about the vocabulary. What do you see that the other graphs don't have? That dotted line, right? That's called a horizontal asymptote. Okay, you'll hear asymptote a lot this year. That is the special case. It is on the y-axis, so it deals with the range. Okay, it deals with the range. So we're not worried about it right now. Let's just look at the domain. How far to the left does this graph go? Forever, negative infinity. How far to the right does it go? Remember, we just talked about it points up and to the right. How far to the right does it go? Positive infinity. And again, parentheses because those aren't real numbers. All right, I'm gonna go to the next one. I will come back to the range. There's a reason for everything that I do, just trust me. What's different about this graph compared to the others? Yeah, so it's got a point at the bottom, right? You guys see that point at the bottom? All right, the arrows both point up. There's no arrow that points down. So this has a minimum. You've heard the word minimum because you've worked with these before, not the absolute value, but quadratics. You've worked with minimums on them, okay? Minimum deals with the range. The range is going to be messed up, all right? But the domain, how far does it point to the left and how far does it point to the right? Have you seen any difference in any of them? No, no. So what do you think all our domains are going to be? For a regular graph, all of our domains will be what? Negative to positive, right? Look at the next one. The only difference in this one is it has a maximum. Maximum deals with the range. It deals with the y. So this one goes left forever and right forever. So if they are normal graphs, no holes, no asymptotes, anything like these have little holes in them and they have stopping points, these will have weird domains possibly, okay? These are normal graphs. Their domains, negative to positive infinity. Their range is what's different. Linear is always going to be negative to positive, always everything. So let's look at this one first. You want to know how low it goes to how high it goes. Where does this graph point? Down forever, right? So what's down forever? And we don't include it. But then it does have a high point. It has a high point right there. What is that on the y-axis? 3. I'm going to draw it right here. Is it a solid point? There's no holes, right? It's completely solid. We bracket it. That means it's included in the domain. Negative infinity, positive infinity will never be bracketed, ever. Again, it's not a specific number, okay? It's just a direction, all right? So let's look at the next one. The next one's kind of the same way, but it has a minimum. So I just write it down right here. Where's this minimum at?
-4.
Thank you. Perfect. Good job. All right. So how low does this graph go? What's the lowest it goes? -4. And it's included because it's a solid point. You'll see what I mean by solid and open when we get to the next 4. And then how high does it go? Low to high. How high does it go? forever because it points up. That's it. Just that simple. How low, how high. Same thing on this one. The only difference is, what did I tell you about this dotted line? What does the graph never do? It never goes below it. It never touches it. So this line is at 1, 2, 3, 4, -5. So here's the difference in this range. The lowest it goes is -5, but it doesn't touch it. So -5 is not included in the graph. How do we show that it's not included? We just use a parenthesis. So anything not included uses a parenthesis. Negative and positive infinities use parentheses. Then how high does it go? Forever. There you go. Okay, don't forget low to high, left to right. Range is left to right. Okay, so you might want to write that. Range is left to right. I'm sorry, domain. Geez, y'all, sorry, it's Monday. And then range is low to high. How low to how high? All right. So remember I told you might need highlighters. If you have some, you might want to get them out. You don't have to. You don't have to. I just do this as a visual for you guys. So if you'd like to get them out, you can. If you don't, that's fine. All right, so let's look at these. We're going to start left to right. So I'm going to do yellow. Here is my leftmost point. Here is my rightmost point. And you can do it with your pencil. You don't have to have it, but it gets a little bit confusing when you do the other side. Okay, so our domain is left to right. What is the leftmost that it goes? What's the leftmost point? Uh-huh. So that vertical line is at -5. Is that an open circle or a closed circle? That means it is not included. How do we write not included? Parenthesis. So parenthesis, -5. I don't like this paper. Sorry, y'all, just give me a minute. All right, check this out. We're going to go across until we see something else crazy. So everything looks good, looks good, looks good, looks good. And then there's a crazy point, okay? There's an open hole, right? So we can't include this one either. So we have to stop our range, our domain. And where is it at? Sorry, just give me a minute. Guys, you got to be on time. Our Zooms start at 8:40. All right, so it's at 2. And again, that's on the x-axis. And then it's not included because it's a hole. But I still have more graph. I still have more graph. So this is how I pick it back up. You do a U, which means union, or say your graph is either -5 to 2, or you pick back up exactly where you left off, 2. We don't have any crazy points until we get to our stopping point. And where is our stopping point at? 6. Is that going to be included or not? So bracket or parenthesis? Bracket. Why is it a bracket? Close point. That's it. Okay. Now, when you do your range, you got to think opposite. Low to high. So here's my lowest point. Here's my highest point. Watch out for those arrows. This one didn't have any arrows, so it's a little bit easier, okay? Remember, range is low to high. So what's our lowest point on the y-axis? -1. Is it open or closed? Open. So how do we show that in our range? Parentheses. Perfect. Our lowest is -1, but it's not included. All right, so this is where it gets tricky. You ready? We're going to move up and stop when we see an inconsistency. So right here, this hole. However, if you look across my yellow Post-it note, is there a solid point? It closes it off. You just ignore it, okay? So it's like it fills it in. Make sense? So they dug a hole, but then they filled it up. So we don't care about that. We're going to keep going. And then we stop at our highest point, and I'm going to take this paper down so you can count. What is your highest point?
6.
6. Is it bracket or parentheses? Bracket, because it's closed up. That's it. Y'all, that's it. All right. Do they get a little more complicated? This arrow throws a kink in it sometimes. Just be careful, okay? Just make sure you see the arrow as an arrow and not as a dot, okay? So when we look at the next one, what does this arrow tells you it keeps doing? 2 directions. What 2 directions? Left and up. So you might want to write that, left and up, so I don't screw it up. Now on the other side, it's fine. All right, so our domain. What does the arrow tell us about the left? Forever. So negative infinity. So we got the arrow, yay. We're going to go left to right. We see an inconsistency, and there's an inconsistency at what? What on the x-axis? -2. Is it open or closed? It's open, so it's a parenthesis. How do we start again? Because we have more graph. We put a U, and then what do we put? Same thing, -2. I'm going to keep going, and everything's solid until I get to the very end. And I stop at what point on the x-axis? I just didn't hear you if you said it. 5. And do I do a bracket or a parenthesis? Why do I do parentheses? Because it's open. That's it, y'all. That's domain and range. That's all you have to do. All right, range goes from the bottom to the top. So I'm gonna start at the bottom, and there's already an inconsistency at the very bottom. Where is it at? -5. Since it's open, we use a parenthesis. As I move up, I see another inconsistency, but do I write it down? No, we fill it in with that other hole, so we just keep moving. We just keep moving. And then I see an arrow, and what does that arrow tell us? Up to positive infinity. Not included ever. That's it. Okay. We have 2 more, and then I'm not going to make you write the equations. We'll probably do those tomorrow to start with, and then we'll finish out. Okay. All right. We're going to go left to right. Be careful on this one. Look on the left. What do you see on the left? Infinity. What kind of infinity though? Negative infinity. As we keep moving, we have an inconsistency at -2, so it's open. We pick it back up because there's more graph. And when we get over here, what do we have? Another arrow that goes to infinity. Perfect. Just watch those arrows. All right. So your range. This is the one that'll throw you off. Are you ready? What is your lowest point? We got it one more time. Here's why. What does this arrow do? So they try to cheat you on this, right? So we're going to extend this so you guys can see it a little bit better. So don't get caught on that right there, okay? Be careful, because a lot of people will, and then they'll get up there and forget that there's an arrow. So actually, how far down does it go? Negative infinity to start with. And then we get up to that inconsistency at what? -5. Do we write that down though? Are you sure? Check it out. Why? Yeah, see, it fills itself in. It's touching another part of the graph. So that doesn't even count in this thing at all. So this is probably the trickiest one on here is this one, okay? We can move on up, and we don't see any more inconsistencies till we get to this line right here. Where is this line at? 5. And is it included or not? No, because it's a horizontal asymptote. So that's a tricky range. So just be careful of those arrows. That's where I said you got to watch those arrows. They're sneaky. The next one doesn't have any arrows, so it's kind of like number one or the very first one that we did over here. So we're just going left to right. What's your leftmost point over here? -6. Is it included or not? Included, so we use a bracket. We move on over till we see an inconsistency. There is no other graph touching my Post-it note, so I know that I have to stop here. Where is it at? Since it's a whole, we use parentheses, and we pick back up where we left off. We're going to keep going to the right until we see another inconsistency, and it's at the very end. And where is that at on the x-axis? 7. We do not include it because it's open. Last part, your range. We're going to start at the bottom. There's no arrows to throw us off, so we're going to get to the bottom point. Where is that bottom point at? -4, included or not? Included, very good. We're going to go up to see any inconsistencies. We do see one, but what happens? Do we use it? No, because we have graph over here touching my Post-it note too. If you guys need a Post-it note from here, tell me, let me know, I'll get it. We're going to keep going up until we see another one. We're good, we're good, we're good. Okay, at the very top, I have one. Where is that at? 6. Is it included or not? No, because it's open. That's it. That's domain and range. Okay. So the only thing that we have left is writing equations. And those are fairly easy when it comes to linear and absolute value, but it's a little more trouble when it's quadratic and exponential. So we're going to talk about those tomorrow. I think I'm going to stop right here. We've been going for a long time. So we'll do those tomorrow. Let me stop recording. Don't go anywhere.